Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problem for GMAT out of this book here. The GMAT review, the official guide. If you do not own this book already, it's imperative that you acquire one immediately. You will find it at mba.com. The problem that I'm about to solve is the one that you will find on page number 172, problem solving 147. Let's take a look at it. Again, you have to have the book in front of you so that you can follow my work and you can read the problem yourself. It says, in the picture above, well, let me draw the picture first. In the picture above, V represents an observation post at one end of the pool. Alright, so here's your picture. There is our V. We are told that this distance is 5 feet. I don't write down the unit because it's immaterial. Whether it's 5 feet or 5 inches or 5 meter, it doesn't really matter. The unit plays no role in it. In the picture above, V represents the observation point at one end of the pool. From V, an object that is actually located at the bottom of the pool at point R. So something that is located at point R, because of the refraction of the light, not reflection but rather refraction, the bending of the light in the water, the object that is actually located at the bottom of the pool at point R appears at point S. So something that is located at point R, it appears to be at point S. It appears to be farther away than it actually is. We are told that V to R is 10. Okay. So I'm told that this distance is 10 feet. The question simply is, what is the distance RS in feet between the actual position and the perceived position? Alright, very good. Let me make this thing straight. It's just kind of crooked. I don't like it. I'm not quite sure if they were thinking of me when they came up with the word anal, but anyway, I like to, so I fixed it. But that's all it is. Basically, we have to figure out the distance R to S. That's all it is. How are we going to do it? We know that V to R is 10. Oh, and I left out one more information, which is, oh, V to R is 10. Let me start again. In the picture above, V represents an observation point at one end of the pool. From V, an object that is actually located at the bottom of the pool at point R appears to be at point S. If VR is 10 feet, V to R is 10 feet, what is the distance RS in feet between the actual position and the perceived position of the thing? Oh, very good. Very nice. Let's see what happens. And we are told that the distance, you see, this is the part I left out, all the way from here. Let's give this vertex a name. I'm going to call it Q. All the way from Q to S. This is the part that I was missing just now. We are told that that is 10 feet. Well, I'm going to get going then. Took me a while because I wasn't paying attention. Let's get going. So very first thing we have to do is figure out the distance Q to R. I'm going to redraw this triangle here. I'm going to reproduce it. Here we go. This is my Q. This is my R. I'm trying to figure out this distance here. This distance from here to here is what I'm trying to figure out. I know that the hypotenuse is 10, which is my V to R. Q to R, I'm told, is 5. So a simple application of Pythagorean theorem will tell me what is this distance. Once we figure out what is Q to R is, then figuring out R to S is very simple. We just take that distance, subtract it from the 10, and that's our answer. Let's do it then. So Pythagorean theorem tells me that the hypotenuse square, which is 100, let me do it step by step so I don't lose anybody. 10 squared has to be 5 squared plus x squared, this right here. 5 and x. Bring the 5 square on this side, so x squared equals 100 minus 25 and x equals square root of 75. This thing right here is square root of 75. So we are ready to start chopping down answers. How much is square root of 75? Let me repeat my question again. How much is square root of 75? That is the question that you will have to answer in the exam. To which my answer would be, how the hell do I know? I do not go around memorizing square root of 75. Do you? But there are some things that I do go around memorizing for the exam, which is square root of 64. I know that 8 squared is 64. Therefore, I know the square root of 75, whatever it is more than 8. It's more than 8. This is how I write. Let me write it again. X, this x here, whatever that is more than 8. How much more than 8? I don't know, slightly more than 8, or somewhere halfway around the 8, because on the scale, this is 64 and this is 91, which is the square of 9, and this is the square of 8. Since I'm looking at 75, it's somewhere between 8 and 9. I don't know how much it is, but it's more than 8. Stay with me in the story, okay? That's what it is. A simple logical thinking is what is required here in order to get a decent score. One does not need to be a geek, like a nerd, trying to figure out every single thing mechanically in a mathematical way. You could do that if you wanted to, if you have the time and if you have the inclination. I don't. So, square root of 75 again, one more time. My logic tells me that it's more than 8. How do I know it's more than 8? Because square root of 8 is square root of 64 is 8. If the square root of 64 is 8, the square root of 75 has to be more than 8. So if this guy is more than 8, if x is more than 8, it stands to reason that this distance q r to s, whatever it is got to be less than 2. This distance has to be less than 2 if this is more than 8, because the whole thing is 10. Let's look at the answer choices. I'm going to show you now. I'm going to show you now, within seconds, how you can raise your odds to 50-50. And even if you don't have the time afterwards, or if you don't know what to do next, 50-50 chance is better than just getting stuck there or wasting your inordinate amount of time trying to figure out exact square root of 75. It's not necessary. Let's look at the answer choices. I know the correct answer, whatever it is less than 2. The correct answer, whatever it is less than 2. That tells me that E is wrong, which is 4. It tells me D is wrong, it's 2.5. It tells me C is wrong because it is 2. The contest is between A and B. Let's take a look at B. B tells me 10 minus 5 times root 2. 5 times root 2. Let me take a look at the camera. I'm going in a very leisurely pace here. I don't want to run out of time. Oh boy, I'm at the 8.5 minutes mark here. You do have to know square root of 2 by heart for the exam. The square root of 2 is 1.4. The square root of 3 is 1.7. You should know this by heart. Therefore, this B is 10 times 5, 1.4. I know that 1.4 times 10 is 14. Therefore, 1.4 times 5 would be 7. This quantity in B is approximately 3. Big quantity in B is approximately 3. It is still too large. The answer is A. Answer is A. Because A says, oh, there you go. A, I'm going to do it here for the bottom part here, if I have the time. 10 minus 5 times root 3. Root 3, as I told you, is 0.17. And where did this come from? You have to know this by heart. 10 times 5 minus 1.7 is going to be less than 2, which is what I'm looking for, less than 2. Because 1.7 times 10 is 17. This is going to be approximately 1.5. That's your answer. Answer is A. Listen, if you find this kind of this kind of thinking helpful, and if you wish to purchase my videos in which I show the solutions to all the problems, or if you wish to hire me for personal private tutoring, in either case, go to my website at prep4gmat.com and send me an email. Alright? Thank you.